and welcome to a fresh new edition of your favorite program, Science Monitor, a program that keeps you updated on all that is happening in the world of science and technology. Let us begin by taking a look at the headlines. PSLV C23 successfully launched. World's biggest gamma-ray telescope to be set up at Ladakh. A UN public lecture organized on the subject of climate change and sustainable energy. Indian scientists and students participate in Bio 2014 being held at San Diego. A new species of lizard discovered in the northwest coast of Maharashtra. And in our segment In Focus today, we will discuss about Japanese fever. And now news in details. On the 30th of June, the Polar Satellite Launch Vehicle or PSLV C23 was successfully launched by Indian Space Research Organisation at Sriharikota. The Honourable Prime Minister of India, Mr. Narendra Modi, was also present at the Mission Control Centre at the time of the launch. He congratulated all the scientists after the successful launch of PSLV C23 and encouraged them to work in close coordination with well-wishers for the country's development. Here is a report.
Adding yet another proud moment to India's glorious history of space research, India's Space Research Organisation on 30th June successfully launched the PSLV C23 rocket carrying 5 foreign satellites from 4 countries. The Polar Satellite Launch Vehicle C23 was launched from Satish Dhawan Space Centre in Sriharikota at 9:52 am. PSLV C23 was carrying 714 kg French Earth Observation Satellite Spot 7, which was its primary payload along with 14 ASAT satellites of Germany, NLS 7.1, CAN X4 and NLS 7.2 CAN X5 satellites of Canada, each weighing 15 kg and 7 kg Velox 1 satellite of Singapore respectively. According to the reports, PSLV C23 precisely placed all 5 satellites into their intended orbits between 17 and 19 minutes after liftoff. The 5 satellites have been launched under commercial agreement that ISRO's commercial arm, Antrix, has entered into with the respective foreign agencies. ISRO has so far launched 35 satellites from 19 countries around the globe. The launch was attended by Honourable Prime Minister Shri Narendra Modi. Congratulating the team of researchers involved in the development and launch of PSLV C23, Shri Modi applauded the mission as global endorsement of India's space capability and called upon the Indian space community to take up the challenge of developing a SARC satellite along with enlarging the footprints of India's satellite-based navigation system to cover all of South Asia.
India will very soon set up the world's second biggest gamma-ray telescope to reveal the mysteries of the universe. This 21-meter long telescope will be set up at Hanle in Ladakh. Recently, the vehicle containing this telescope was flagged off by the chairman of Atomic Energy Commission from Hyderabad to Ladakh. This indigenously built Indian telescope has been assembled by the scientists and the engineers of ECIL.
The Major Atmospheric Cherenkov Experiment Telescope, shortly known as MACE, was flagged off to its destination on 28 June by Dr. R.K. Sinha, Chairman Atomic Energy Commission and Secretary Department of Atomic Energy. MACE telescope has been developed indigenously by the Bhabha Atomic Research Centre in collaboration with Electronics Corporation of India Limited. The 21-meter diameter MACE telescope, designed to perform under extreme weather conditions, will be set up at Hanle in Ladakh. MACE is the second largest gamma-ray telescope in the world.
This is something which gives us great deal of pride that India is going to have this. The second reason why we are proud is that this is an entirely indigenous effort. It gives me great pleasure to declare that this assembling and the testing work for this device MACE telescope has been completed. As far as ECIL campus Hyderabad is concerned, it is going to be shifted piece by piece in several truckloads to Hanle. Of course, you must be knowing there is a certain time window only during which such movements are possible. They will do it. It will take time to assemble and integrate over there. We hope it will be operational in early 2016 after this is done, and this will become one of the main focus labs for the international astrophysical communities as well, and India will be the leader of them.
The telescope will be fully operational by early 2016. MACE is fitted with mirrors made of aluminium honeycomb panels, diamond turned to 50 nanometer surface accuracy. The telescope is expected to gather crucial information that will further increase our understanding in the fields of astrophysics, fundamental physics, particle acceleration mechanism for gamma ray generation, and spectral cutoff of pulsars. MACE has been developed by the Astrophysical Science Division, Center for Design and Manufacture, Electronics Division, Reactor Control Division and Reactor Safety Division of BARC in collaboration with a team of 25 scientists from ESL over a period of 4 years. Indian Institute of Astrophysics, Bangalore and Tata Institute of Fundamental Research, Mumbai are also associated with the project. According to the current schedule, the total mechanical structure of the telescope is expected to be shifted to Hanley by August 2014 and assembly work is to start by September 2014.
TERI recently organized a United Nations public lecture on the subject of climate change and sustainable energy. The lecture was addressed by the Director General of TERI and Chairman of the Intergovernmental Panel on Climate Change, that is IPCC, Dr. R.K. Pachauri. During his address, Dr. Pachauri, while stressing the importance of usage of renewable sources of energy, said that such energy sources are not only useful to fulfill our energy requirements, but can also prove to be helpful in boosting our economy.
The third United Nations public lecture on climate change and sustainable energy was delivered by Dr. R.K. Pachauri, Director General, the Energy and Resources Institute and Chairman of the Intergovernmental Panel on Climate Change on 28 June at New Delhi. Addressing the issues related to climate change and sustainable energy, Dr. Pachauri expressed concern over the massive energy deprivation faced by a large part of Indian population.
Energy in its various forms has been such an intimate part of human existence that not to have given it primacy in everything that we did in terms of policies, in terms of strategies that we planned for in the future, would really have been a major exclusion.
He said that the challenge to provide energy access for all has to be seen in the context of the problem of human-induced climate change, the impacts of which would create very high vulnerability for India in a large variety of ways. Dr. Pachauri called upon all the stakeholders in Indian society to participate and contribute towards tackling the challenge of climate change and sustainable energy. He also pointed out the need of ensuring access to electricity and clean cooking fuels in every remote corner of India.
Major issue which we discussed today at the public lecture, this is really going to be one of the issues to highlight energy issues. And then in a country like in India, energy deficiency is the major maybe factor which hinders the development index. And I'm not really going to talk about statistics, but the availability of the energy is so erratic and not reliable. And then, of course, there are lots of mini grid or national grid is really being established. But the problem is that availability is not really assured in time and on time.
Speaking on the occasion, Lizzie Grant, United Nations Resident Coordinator, stressed on the importance of accessibility, affordability, availability and accountability of energy resources, while Ayumi Fujino, UNIDO representative for India and Regional Director for South Asia, added that amongst all the A's, ensuring accountability is the most critical element.
A group of scientists, students and industrial experts from India participated in the ongoing Bio 2014 being held at San Diego, USA. The group was headed by the Secretary of Biotechnology Department, Dr. Vijay Raghavan. Here are the details.
Demonstrating its great potentials and opportunities it has to offer to the world, Department of Biotechnology India was one of the key players of the 2014 BIO International Convention. The convention was held at San Diego, California during 23rd to 26th June. The Indian delegation, consisting of government officials, state government agencies involved in the promotion of biotechnology, industry representatives, startups and academics, was led by Professor Vijay Raghavan, Secretary, Department of Biotechnology, Government of India. Speaking on the occasion, Professor Raghavan highlighted the scope that biotechnology research in the country holds for Indian students abroad. India during the convention focused on fostering collaborations and skill development of youth. India Pavilion at Bio 2014, consisting of exhibits of several biotech firms, startups and MSMEs, triggered avid interest among the participants. State government of Tamil Nadu, Karnataka and Uttar Pradesh were also a part of the pavilion and reached out for trade and investment. The Bio International Convention is hosted by the Biotechnology Industry Organization and represents more than 1,100 biotechnology companies, academic institutions, state biotechnology centers and related organizations from around 30 countries. Bio members are involved in the research and development of innovative healthcare, agricultural, industrial and environmental biotechnology.
A new species of lizard has been discovered in the northwest coast of Maharashtra. It has been named as Snemaspis giri in honor of Dr. Varad Giri of the Natural History Society. This discovery has been made by 4 research scholars of the Bangalore-based National Centre of Biological Sciences and Centre of Ecological Studies. Here is a report.
In an interesting new study, 4 researchers from Bangalore's National Centre for Biological Sciences and Centre for Ecological Studies have discovered a new species of lizard in the northwestern Ghats of Maharashtra. The species has been named Snemaspis giri after Dr. Varad Giri of the Bombay Natural History Society. The lizard belonging to the genus Nemapsis or dwarf geckos was discovered in the unexplored forests of the Khas Plateau in Satara district. The species was first spotted way back in 2010 by Harshad Bhosle and Zishan Mirza. The researchers then, with the help of Sonak Pal and Rajesh Tanap, compared the species with existing specimens and established that the lizard belongs to a new species previously unreported.
It is time to take a very short break here. We will be back with more science news. So stay tuned. Welcome back after the break. You're watching Science Monitor. Let us now take a look at some other significant scientific activities across the globe in our segment Science Express.
The 14th batch of Indian students and young researchers have left for Germany to participate in the 64th meeting of the Nobel laureates and students scheduled to be held in Lindau, Germany during June 30th to July 5th, 2014. The Indian team, comprising 20 graduates, postgraduates, doctoral students and postdoctoral researchers, including 8 female students from the field of medicine and physiology and related subjects, were selected by the Department of Science and Technology. About 35 Nobel laureates and 600 young scientists from 80 countries are participating in this meeting. In a major step towards conservation of tigers in India, the Minister of State for Environment, Forest and Climate Change and Chairperson of the National Tiger Conservation Authority, Shri Prakash Javadekar, has approved the recommendation on a proposal from the state of Maharashtra for notifying the Boar Wildlife Sanctuary as a critical tiger habitat, thus making the sanctuary 47th tiger reserve in the country and the 6th tiger reserve of Maharashtra. The minister also approved the recommendations to establish ecological baselines for long-term monitoring of tigers in Dibang Wildlife Sanctuary in Arunachal Pradesh and extension of an ongoing research project on intensive monitoring and study of tigers dispersal in the Kanha Tiger Reserve of Madhya Pradesh. NASA, in its first dedicated missions to study atmospheric carbon dioxide and assess human contribution to greenhouse effect, launched the Orbiting Carbon Observatory 2 (OCO-2) satellite from Vandenberg Air Force Station, California on 2nd July 2014. The satellite is designed to provide deeper insights into the processes that govern carbon dioxide's atmospheric concentration and tracks the sources and sinks of CO2 across the globe. This will be an important step towards assessing the contribution of human activities to global warming. As yet another recognition of India's potential, the US Geological Survey has named a mountain in Antarctica as Mount Sinha in honor of the Indian-American researcher Dr. Akhori Sinha, adjunct professor in the Department of Genetics, Cell Biology and Development at the University of Minnesota, whose pioneering biological research expedition during 1971-72 has provided critical data about animal populations. Dr. Sinha is recognized for his work on cataloguing population studies of seals, whales and birds in the pack of ice of the Bellingshausen and Amundsen seas.
We often hear news about patients suffering from encephalitis or Japanese fever. Recently, the Health Ministry of India has also started a vaccination program against encephalitis in Bihar. Today, in our segment In Focus, we will throw light on this disease, encephalitis.
Of the many infections and diseases that plague humankind, encephalitis is a rare infection that occurs in approximately 0.5 per 1 lakh individuals, most commonly in children, the elderly and people with weakened immune system. Encephalitis is defined as inflammation of the brain and is caused by various agents like viruses, bacteria, parasites, chemicals, and in some cases as a result of autoimmune reactions. Of these factors, viral encephalitis is known to be the most common. Viral encephalitis is known to be caused by a range of viruses like the rabies virus, herpes simplex, poliovirus, measles virus, varicella zoster virus, etc. The inflammation of the brain can be a direct result of an acute viral infection or as a consequence of latent infections. Infection by various viruses like the Japanese encephalitis virus, St. Louis encephalitis virus, West Nile virus, Eastern equine encephalitis virus, Western equine encephalitis virus, variola minor virus and variola major virus are also known to cause viral encephalitis. Bacterial encephalitis is caused as a result of acute bacterial infections like syphilis. Certain parasitic or protozoa infections like malaria is also known to result in brain inflammation. Encephalitis is classified into two types, namely primary and secondary. Primary encephalitis occurs when a virus or other infectious agent directly infects the brain. The infection may be concentrated in one area or widespread, while secondary encephalitis refers to the condition where the immune system goes faulty and mistakenly attacks healthy cells in the brain. It is important to note that mosquitoes and ticks are known to transmit the viruses for several types of encephalitis. Since encephalitis often accompanies other viral infections, the symptoms are hard to differentiate and the inflammation is difficult to diagnose. However, the common symptoms include fever, headache, poor appetite, loss of energy, a general sick feeling. In several cases of encephalitis, a person is more likely to experience high fever and symptoms associated with the infection of central nervous system like confusion, problems with speech or hearing, seizures, memory loss and hallucinations like perception of foul smells, etc. Symptoms in children and infants include vomiting, a full or bulging soft spot of the skull, body stiffness, poor feeding, irritability. For most forms of encephalitis, the symptoms usually last up to a week, while complete recovery can take much longer, often several weeks or months. But in acute cases and if left untreated, encephalitis may lead to permanent brain damage and lasting complications like learning disabilities, speech problems, memory loss or lack of muscle control, and in rare cases, even death. Hence, it is important to seek medical help on the onset of the symptoms. The diagnosis of encephalitis include imaging tests such as computed tomography, scans or magnetic resonance imaging of the brain, electroencephalogram, blood tests and lumbar puncture or spinal tap, which involves testing the cerebrospinal fluid for infection. Encephalitis is usually treated using drugs, antivirals or antibiotics, corticosteroids and anticonvulsants. Vaccinate children against viruses that can cause encephalitis like polio or measles. Japanese encephalitis can be prevented with 3 doses of the vaccine. Take precautions when traveling to areas where this strain is common.
In order to promote innovation, it is important that we create an environment which is apt for realizing our dreams. IIT Madras has prepared a lab in which students are given a free hand to work on any project of their choice. All necessary facilities are provided in this lab. Center for Innovation is a platform which has been set up with the help of erstwhile students of IIT. Here is more.
In the rapidly changing industrial climate of the world, innovation is the buzzword. Creative endeavors that break routines and introduce novel ways of thinking is fast being accepted as the key to socio-economic development. The Center for Innovation of Indian Institute of Technology, Madras is one such endeavor focused on fostering innovations and inspiring young minds. No one who enters the beautiful IIT Madras campus is likely to miss the Center for Innovation, the popular student lab which was set up using funds donated by the batch of 1981 right in the middle of the academic zone.
So, the idea was that you walk in with an idea and walk out with a product. That was the idea, that was the tagline that was used, and students who wanted to do such things now had a place where they could do these things without much of a problem. They did not have to approach the administration, etc., in order to be able to do these activities.
The CFI, designed to stimulate creative thinking, promotes the concept of non-linear and adaptive thinking and envisions to promote informal learning and foster innovation and invention in technology, with focus on technologies aimed at contributing positively to the environment and to the society.
In Center for Innovation, we are getting all kinds of technical facilities. So, we require facilities for building the robot, like mechanical structure of the robot, drilling, then doing some cutting jobs and all. After all, even the electrical architecture which can be seen in the robot has been customized by the students itself. So, in Center for Innovation, we get the facility to design these PCBs and then do some coding for the robot to do some navigation tasks under the water.
Aiming to encourage the young engineering students to follow innovative pursuits and develop free and radical thinking, the center promotes the concept of walk in with an idea, walk out with a product. Students are encouraged to come up with novel ideas, and the futuristic lab setting of the center facilitates the translation of these ideas into products. CIF also supports large team projects and encourages the students to take part in international contests such as Robocon Robotics, Formula SAE, International Aerial Robotics Competition IARC, or Federation of International Robotics Association FIRA. These projects are also showcased at the Shastra series of Spirit of Engineering SOE projects. One of the main objectives of the center is to promote inclusive innovation and thus encourage the students to undertake socially relevant projects to address the issues prevalent in India along with environment-friendly solutions. Needless to say, such innovation centers that capitalize on the creative abilities of students are the need of the hour, and there indeed exists an urgent need to integrate and foster innovative thinking as a part of our education system.
And now, what is the contribution of science in the annals of history? Let us watch our segment, History of Science.
On 7 July 1843, Camillo Golgi, Italian physician and cytologist, was born in Corteno, Italy. He worked out a method of silver nitrate staining nerve tissues. In 1883, he discovered the presence of an irregular network of fibrils, cavities and granules in nerve cells, now known as Golgi complex or Golgi apparatus. He proved that Golgi apparatus is found in all cells except bacteria. He also made some important observations of malaria parasite, showing that the severity of malaria attack increases as the number of malaria parasite in the body increases. Golgi was awarded Nobel Prize in 1906 on their work on structure of nervous system. On 9 July 1926, physicist Benjamin Roy Mottelson was born in Chicago, USA. Mottelson, along with Aj and Bohr, developed a structural model of atomic nucleus in 1951. From their experiments, they discovered that the motion of subatomic particles could distort the shape of the nucleus, which is claimed to be perfect sphere. Mottelson was awarded the 1975 Nobel Prize for Physics jointly with Bohr and the American physicist James Rainwater for the discovery of the connection between collective motion and particle motion in atomic nuclei and the development of the theory of the structure of the atomic nucleus based on this connection. On July 9, 1957, discovery of element 102, nobelium, NO, was announced. This discovery was announced by a group of scientists working at the Nobel Institute of Physics in Stockholm, Sweden. Scientists produced this element by bombarding a target of curium-244 with ions of carbon-13 using a device called cyclotron. The element nobelium is named after the Swedish inventor Alfred Nobel, who invented dynamite. 10 isotopes of nobelium are known to exist now. On July 10, 1908, helium was liquefied for the first time by the Dutch physicist Heike Kamerlingh Onnes. Helium was liquefied at a temperature of 4.2 Kelvin, that is about -269 degrees Celsius. The gas was liquefied by compressing it, cooling it below the inversion temperature and then allowing it to expand, which resulted in further cooling causing liquefaction of some of the gas. This liquid air was used to produce liquid hydrogen and then the liquid hydrogen to jacket the liquefaction apparatus to produce about 60 milliliters of liquid helium. Kamerlingh Onnes received the 1930 Nobel Prize for his work in low-temperature physics.
That is all in this edition of Science Monitor. So how do you like our program? Well, do send in your comments and suggestions on our email ID news@vigyanprasar.gov.in, or you can also write into us. Our address is Vigyan Prasar, C24, Kutub Institutional Area, New Delhi 110016. That is all in this edition of Science Monitor. We will again meet next week with more science news. Till then, goodbye.